How's it everyone? My name's Gordon. Testing time logic in applications can get complicated, but today I'm going to show you how we can simplify it all. Let's take a look. Okay, so we've got this .NET Web API. It's pretty standard. The only real change that we've made to it is a method here that says get the days until the next Sunday. And then what we're doing is using that here for the range so that we'll get a different amount of days depending on how many days we are away from 2 Sundays from now. Okay, so over in Postman, we can see here's our URL to the weather forecast. We're going to do a GET request. So when we do that GET request, we can see that the date is returned, in this case running from the 3rd through to the 12th of March. Go ahead and run it again. The data randomizes the way you're used to from this API. Now I've got one test here, which in itself sort of shows what the problem is. Because I was meant to do this video yesterday, and then I delayed it a bit. But at the moment, the expected results here is 11. Now, if we go ahead and run this test, it's going to fail. So you can see this test failed, and if we go and open that, we'll see that the reason for that is that the count was wrong. Let's get deeper. There we go. So I was expecting 11, it found 10. Now, obviously, this is easier to fix. We're going to put that to 10, save this, run it again, and it works, right? The problem is, who's going to be changing our tests every single day? Now, another approach would be that we have that same method that works out how many days we are until next Sunday, and we put that into our test, and then they match. The only problem is, what happens if both of those pieces of logic have errors in them? So let's take a look at how we would look at fixing this instead. So the first thing we're going to do is we're going to revert this 10 back to 11, because that's what we wanted to test. Even though it's 10 days to next Sunday, we want to make sure that our test passed with it being 11. The next thing we're going to do, and for your API you most likely won't have to do this, is we're going to add our system clock. And the reason you won't have to do this is if you can look at the interface, well, the implementation that we're injecting, it comes from the ASP.NET Core authentication namespace. So if you are using the default authentication at ASP.NET Core, you'll already have this injected in because the framework itself uses it. Next up, we're going to go to the controller and we're going to add the our system clock interface, and we will just create a local member for that. And then we're going to go ahead and use that inside our method. So over here where we're calling datetime at the moment, we're going to go and call the system clock UTC now add days like it used to be, and then we're going to grab the UTC date stamp. And then at the bottom where we were doing our little calculation here, we're going to go and switch that out as well for the system clock. Again, UTC now and then add days. Okay, so the next thing we're going to do is we're going to go to the web application factory, and we're going to go to the configure test services method, and we're going to drop this snippet of code in. So let's just clean that up, format that, and drop that property at the top. Okay, so let me explain what we got here. The first thing we got is a dictionary, which is going to have some sort of a key, and then a datetime offset that should get used for a test. The next thing that we're doing is we're mocking out the our system clock, and then our mock for that is going to get a HTTP context accessor, and it's going to check the header of the current request if it's got an X test time header in it. If it does have that header, we're going to pull out the time key, and then we're going to check the test times dictionary if that time key exists. If it does exist, we're going to extract the time key out. And then we're going to add a millisecond, and then we're going to go ahead and update the time in the dictionary to be our new time. So the idea here is that before you call your method, you'll hit the static dictionary and say, I've got a time key called web1 or random good, and then you'll update the header to be that same random good. And when this comes through, any calls for the API that use the our system clock will get a time from the point that you put into the dictionary and then each time moving 1 millisecond forward. So this will make sure that the different functions getting times will still actually get a time that is chronologically after the previous time, so that you won't have everything getting the same time. So if you're running this in your normal app, you'll see this actually is called quite a lot of times with authentication stuff, because as I mentioned, the ASP.NET Core framework itself uses this for authentication. Okay, so what I've done now is just switched on live unit test just so that it's easier to see which code paths are being called. So you can see at the moment this little chunk here that fetches our test time is not being called at all, which is what we would expect because we haven't implemented it. And then if we go to our method, although our last run through Test Explorer succeeded, the run here has failed. So if I go and paste in some code, what we're going to do is generate a GUID, which is the time key. We're then going to set our time to be yesterday at 9 o'clock in the morning, or UTC, and then go and add that to the test factory, add the header to our HTTP client, and then obviously when we use that HTTP client, as you can see as I pasted that in already, this test will then go and pass. And if we go look in our factory, that passed as well. In this case though, we never loop through to here because we don't have any tests that now test that last line. That's all that I've got for you today. If you did like this, please subscribe, share it on your social media. Also, obviously, like it. That's important. Trying to regrow the channel after I moved off the other one. Thanks. Cheers.